Alright, David Harry here, and what it is, I've recently been trying to find the cheapest 1TB external SSD storage solution that I could find. Basically something for like moving data and picture files from like computer to computer, and also to kind of like, you know, do backups while I'm out and about and stuff via different devices and whatnot through a computer and whatnot. Anyways, what I've done is managed to find the best solution or the cheapest solution for doing that particular job. And what it is, it's to get a 1TB 2.5-inch SSD, which is just a standard SATA drive, and then also get myself a USB 3 or USB C to be more precise case, and then combine them together and then get myself a 1TB system which is portable and external. Now basically this has ended up costing me less than £100, and for you guys in the States you can do this for about $105. So let me just crack in and explain what these are. I'll put them together and then we'll do some speed tests as well. So just before I kick into showing you the two components that we're going to use to put this external drive together, at any point during the video, if you want to go and grab these for yourself, there's going to be links in the description below to Amazon where you can buy both of these bits. Anyway, so the first thing is the 1TB SSD itself, and this is, like I say, the SUNBOW or SUNBOW, however that's pronounced, and that's basically just your standard SSD drive. So this is just going to be a SATA 3 drive. It's the cheapest SSD that I could find at 1TB, and it seems to work really well. So there we go, that's a simple packaging. Let me just see there, you get a little thank you thing inside there. I'm not too bothered about these things because I just need to crack on and show you how to put it together. And then what we'll do a bunch of speed tests on it as well. And then there we go, so that's all the basic information on the back. So what this is, it's the X3 1TB drive by SUNBOW. Okay, so let me just throw that to one side. And the second component that we're going to use for this little simple build is a case by UGREEN. Now what it is, this is a USB 3.1 compliant case, or basically it's USB-C. Also it'll do up to 6 terabytes as well. That doesn't bother us because we're only using a 1TB drive. And also it says it's a 2.5-inch compatible, which is fine because it's a 2.5-inch that we're using. Now what I'll do, I'll just do a little bit of a thing here so you can have a look at some of the other specs of the case. But the two things that are like the most important for us here, or the few things actually, what it is, it's UASP compliant. Now as long as you're using UASP or the USB interface that you're using, that you're plugging it into, is compliant with that, this will also be the fastest way of getting the data off and on. If you've ever used cheaper USB 3 cases, sometimes you might only get 150 to 200 megabytes a second out of them, but this will hit the drive at full speed. Also as well, somewhere it says it's Gen 2, other places it says it's Gen 1. Well, regardless of what it is, its actual maximum data bit rate or data transfer speed is 6 gigabits per second, and that is well fast enough to cater for the maximum speed that the actual SSD can do. Now, just to expedite things a bit more, I've actually already opened some of this stuff up, so let me just show you what's in the box. So there's the case itself. Comes with a manual. The box was inside that, but I've just took it all out because we didn't really need to see me unboxing it. And then we've also got a USB-C to standard USB interface here as well. So let me just see if I can get a quick close-up on this. Okay, so as you can see there, on one end of the cable there's USB-C, and then on the other end of the cable there's standard USB 3, and then on the back of the drive itself, as you can see there, there's the USB-C interface on the back of that. So let me just start throwing this together. So there's the SATA drive, and then there's the case, and it's simply just a matter of putting that inside there, and it's very easy. It's a toolless design, this case, which means you don't need to screw any screws. So just flip it over like that, and as you can see here, it's got a little push and shove function, so you just push that in and then slide it off like that. Then what we have here is a SATA interface here, so it's SATA and power there, which just matches up to the drive. We've also got a couple of bits of foam, one there, and they just help to secure the drive in place. Also on the top part there, there's a bit of foam at the back there, which all helps to secure the drive in. So let's see what we do. Just make sure there's the SATA interface there on the drive, and there's the SATA interface of the case. Just basically make sure they're lined up like that, and then just push the drive in. And then what you'll find is it'll just lock with the interface there, and then it'll just click into place. There we go. And then what we simply do is get the door or the back or the rear or whatever you want to call that, and then slide this back on from the back here, and then click in. There we go. So we're all sorted with that. And then what we do, we just use our USB cable there. So we just plug in the USB-C end like that. And then there we go, we're ready to plug that into a computer. So what I'm going to do now is get on and do some speed testing with the drive. So I've now got this external 1TB SSD drive plugged into a USB 3 port on my computer. Now what I'm going to do is just run through a very quick formatting setup. Now I've already done this once with this drive, but I'm going to show you anyway how to do it. And what I'm using here is Mini Tool Partition Wizard. There will be a link to this in the descriptions below, so you can get at this and use this one. So when you launch it, it's going to show you all the drives that's on your system. Now right now, the drive that I'm interested in is this one here, which I've already titled it as external 1TB SSD. So quite literally just right click over it and then click on format. Now at this point you can title that anything you want. Like I say, I've already done this before, so I've called it external 1TB SSD. The file system that I'm using is NTFS because I need to use large files, and also most of the things that I'm plugging it into are going to be able to read NTFS as well. Plus also I use this standalone outdoors with my Chromebook as well, because I use my Chromebook so I can look at video files and build up video bin folders and stuff and all the rest of it when I'm outdoors shooting, ready for when I come in and start editing. Also cluster size, just leave that as default. So basically select all that, name it NTFS or whatever format you want to use, cluster size default, click OK, and then come up here and hit apply, and then hit yes, and then that'll go off and do all the formatting. And there we go, so that's formatted that drive. Now what I'm going to do is just open up 2 folders and let's start seeing how fast it reads and writes. So what we can see here are 2 folders, or basically 2 drives. Now what it is, this drive here, this is an internal SSD, and what this is, it's a Samsung Evo 970 Plus, and basically this is an amazingly fast drive at both reading and writing. So the reason why I'm using this drive as part of the test is because this is way faster than the 1TB external drive. So there's definitely going to be no chance of data bottlenecking going on. So any of the results that we see here is definitely going to be, you know, the drive at its maximum as far as the external SSD is concerned. Okay, and what it is inside here, there's a whole bunch of video files. Now let me just have a quick look at the size. So this is 67 gigabytes. It's got 99 files within 6 folders. So this is going to be very typical for me personally of a lot of the data that I would use this external SSD for, which is mostly video data, and that's either storing or for moving it about, or even when I'm out and about. I use my Chromebook to kind of build up files off my cameras and stuff. You know, basically plug SD cards in my Chromebook and then dump the files off onto an external drive so that when I come in, basically I'm ready to edit and stuff. Okay, so what I'm interested in here is the sustained speed of the writing. So let's just drop this folder and I'll carry on talking. So right now we're kind of moving over quite a large folder with a large number of files in as well. Now, if you're used to doing such things like this, like data dumping from one device to another, and especially SSDs, what you may find is that the first so many gigabytes go along dead fast, and then suddenly it all drops right down after it's kind of exceeded the caching system or something like that. Some SSDs do it different ways than others, but you know, it's very rare that you'll get an SSD to sustain a write speed or a read speed consistently all the way through a large data dump. So what we're seeing here is that we're roughly around, I'd say 375 megabytes per second here. So what I'm going to do, I'm not particularly going to time this, because what I'm interested in here is how fast it does it as far as the data rate is concerned. So what I'm going to do, I'm just going to speed through this and then come back at the end, and let's just see during the speed up, does that kind of speed change much? Okay, so I've just come back in towards the end of that dump there. Okay, so that's gone right the way through there. Now what we will have seen there all the way through, I think the lowest it dropped down to was 369, and it was going up to about 377, something like that. So I think it's very safe to say 370. So I'm saying that the write speed is 370 megabytes per second all the way through that entire dump. So don't forget, let's just double check again. So that was 67 gigabytes, and it didn't once kind of drop right down to like a very slow speed. So that's great. So what I'm going to do here is test the read speed of it. So I'm going to delete that folder there. Let's see, I'm just going to empty the cache, doesn't need emptying. I'm going to rename this folder just in case. Now the reason for doing what I'm doing right now is just to make sure that there's no cached files about that could interfere with this speed test. But to be honest, due to the size and the nature of the data that I'm about to swap back, no caching system on the PC would have took into account this large file or large files. So let's go and see exactly what the read speed is like off this drive. Okay, so it's starting off there at about 355. Okay, it's dropping down a bit. So let's just get a grip of where it kind of evens out. And then what I'll do, again, I'll do the same thing. I'll kind of just speed up through it and let's just see exactly what it's capable of doing. So just kind of drop down a little bit there to about what 425, something like that. It's going down a bit further again. Let's just see what's going on here. It's going back up again, 426, 427, 430. Okay, so what I'm going to do now, I'm just going to do the same thing. I'm just going to stay quiet and let's just see what it runs like as I speed it up. Okay, so I'm going to come back in here again just as it's getting towards the end of this read speed or this read test. Okay, so as you've seen there, it kind of started off at about 455. At one point it dipped right down to 416, but for all intents and purposes it was quite solid all the way through there. And I think just erring on the side of caution, I'm going to call that 420 megabytes a second. May well be a little bit faster than that, but I'd always kind of err on the side of caution with these things. So once again, that whole file there or that whole set of files within there is 67 gigabytes. So I'd safely say 420 megabytes per second as a read speed. Now remember, this is all over an external connection being USB-C, USB 3.1. So what I'm going to do now, I'm actually just going to put the drive inside the computer, connecting it directly via SATA. Just as another quick test, let's just see if there's any differences with that. Okay, so what I've just done, I've just powered down the computer. I've taken the 1TB SSD out of the external USB case and I've just put it into the computer, so it's now connected directly via SATA, so it is now an internal drive. And if I just show you here, as we can see, there are no external USB devices attached. So this is the 1TB drive, which is now connected internally. And again, this is the internal drive. So what I'm going to do is do the write test first, or the write speed test. So what I'm going to do is grab that folder again and move it over. This time I'm going to call it number 3, just so we don't get mixed up. Another quick thing here as well. What it is, I keep checking to see if the recycle bin is empty, because sometimes that just indicates that the files are still available and they could get used as a cached file source. Also as well, I'm changing names, because if you change the name of the root folder where files did reside from, that will actually stop them from being cached or mistaken for cache files if you start moving them about. And plus also on top of this as well, just due to the very nature and size of the folder and the files within it, they can't be cached anyway within this system. And the reason I'm explaining all that, it's just so that we definitely know that the files that are being written over are definitely freshly written files and not duplicates of something that may already be there, which would write faster. Okay, So what I'm going to do now is just drag this over here, let go of it, and let's see exactly what this does. Now there's a bit of a pronounced bump there initially. I think that's gonna have been the basically the onboard RAM cache as well off the very fast Evo 970 Plus. But what we'll see here, it will kind of just start settling at a certain speed. So once again, what I'm going to do, I'm just going to let this run through, sped up, and then I'll come in at the end, and then let's just have a quick observation as to what it was doing as far as the write speeds are concerned. Okay, so again, I'm just going to come into this at the end of this particular speed test. Okay, so there we go, it's done. Now, at one point there, I think I seen that dip very briefly into the 420s. It also peaked up into like the low 450s. So once again, I'm just kind of gonna err on the side of caution here, and I'm gonna call that 430 megabytes per second as far as its write speed is concerned. So once again, I'll just shove the same folder over. Let me just make sure of a few things here. I'll just rename it again. Just give us a second. Okay, so now what we're testing for is the read speed of the drive now that it's internal. Okay, so once again, it will start off at a certain speed. It'll start maybe moving about a little bit. And then hopefully, you know, somewhere along the line here, we kind of get to see a bit of a mean average across its kind of like, you know, consistent data transfer. And okay, so once again, I'll do the same thing. I'll just kind of stay quiet now, speed this through, and come in at the end. Okay, so once again, just coming into this at the end. Let's see, there we go. So that's now managed to go right over. I'd say that was fairly much, very much the same, really. It kind of dipped down into the 420 mark, did go into like, you know, the low 450s. So once again, just erring on the side of caution, I'm going to call that 430 again. So 430 megabytes per second on its read speed when it's connected internally. Okay, so what I'm going to do now, I'm just going to go off and kind of bring up some figures at the end here and do a quick summary. So to the summary, and before I kick into this, what you're probably going to have been asking yourself is, Dave, why didn't you do any of the synthetic benchmarks? Well, for this particular type of testing, the synthetics can actually be quite useless. And by that, what I mean is the synthetics will tell you, like, you know, at varying kind of like data sizes and such, as to like what the speeds are going to be out of a particular drive. But the one thing that they don't tell you is that that drive will not sustain them rates over a given period of time or over a large amount of data. So in the past, I've done synthetics on certain drives, and the synthetics look great and they peak really high and all the rest of it, and it would suggest that even for large files it's going to be mega fast, and it is for maybe the first 8 gigabytes or so, and then suddenly the drive will drop right down and some of them will go below 100 megabytes a second. So that's the reason why I didn't do it with this particular test. And as we can see, or as we did see all the way through this test, they were actually very stable and sustained data rates, which for me are the most important things with regard what this drive is going to be doing as far as an external data drive is concerned. Also as well, I didn't get involved in trying to, you know, go through the manufacturer's figures either, because quite often, unless it's Samsung, you know, I tend to find that the manufacturer's figures can be a little bit off as well. I'm not saying Samsung are perfect, but I generally find that, you know, if you kind of look on Samsung specs, they tend to be great. So again, I don't normally go by, you know, manufacturer's specs and such. Anyway, that's just the reason why I did what I did. And what I did is absolute real world examples. Okay, so let's just have a quick look here. So when it was connected externally, 370 megabytes per second on the write, 420 on the read. Well, I don't know about you, but me personally, for the cost of this system, and right now as of me doing this, this is the cheapest external 1 terabyte SSD, and especially considering it's on USB 3.1 as well. Now, you can get faster write speeds and faster read speeds. I have other drives that have got that as externals, but not for anywhere near the price that I've put this together for. So just again, we have to remind ourselves, this is less than £100 to put together in the UK, and for anyone paying in US dollars, you're talking about 105 US dollars. I did have a good look around, and there's no way at the time of doing this you could do it any cheaper. So yes, you can get faster read and write speeds externally off something else, but it does cost a lot more money. As far as internal speeds, now they did bump up to 430 equally for read and write. Now that difference there, it's not a huge difference compared to what it was externally, but I'd have to say that's probably just down to the chipset in the case. Or just the USB in general, do you know what I mean? Because it's never going to be as good as using a SATA connection, regardless of what variation of USB that's going to be. So realistically, the slight discrepancies that we're seeing there are really, they are slight. I mean, as a for instance, I have another case, which if I put this drive into, it won't go above about 180 in either direction. It's USB 3. Actually, no, it says it's USB 3.1. It still won't do it. So, this case and the cost of it, I think it's performing exceptionally well. And like I say, that discrepancy there between the external and the internal doesn't bother me. Now, if that bothers you, then fair enough. But again, I've got to kind of lean onto the whole thing about its price here, because for the price, I don't think there's much arguing to be done here, and the fact that it does it sustained as well. Okay, so I think I've basically covered everything there, showing you how to put it together, some real world speed examples of consistent data transferring and such. The only one thing I can't tell you is this drive going to last forever? I don't know. I've only just put it together, but so far, I've been using it quite a bit and it's been fine. So that's the only one thing I can't tell you, how it's gonna be over time. But to be honest, you can't really say that about anything you buy anyway. Okay, so hopefully this has been interesting for people, and like I say, if you're interested in putting one of these together for yourself, there's going to be links in the description to where you can get this stuff on from Amazon. And also, if anybody does want to see some hardcore synthetics done with this particular drive internally and externally, just leave some comments below and whatnot. If there's enough people who are into that kind of stuff, I'll definitely try it, because it'll be a lot quicker than this particular video anyway. Alright then, so I think the last thing that remains for me to say right now is, I'm David Harry. Thank you very much for watching this video. Take care and goodbye now.